All right, and just to kick us off, so we're here to talk about Besu, which is an LF Decentralized Trust project. Matthew Whitehead, who's our principal engineer and also a Besu maintainer, is going to kind of give an overview of the roadmap, some deprecated features, some features that are on the way, just talk about what's new and what's next. We plan to save some time at the end for a Q&A. So on your Zoom, there's a Q&A button. And if you want to drop questions in there, we'll try to pull up about 10 minutes before the end to walk through some of those. And then we can also follow up with folks at the end or after the webinar. So looks like we've got a good group here started, Matthew. I can go ahead and hand things over to you if you want to get started.
Yeah, thank you very much, Mark. Are you okay to hear me all right?
Yep, I've got you.
Great, thank you. And welcome everyone who's joining us from a whole variety of countries I can see on the chat. Yeah, welcome to this Kaleido webinar on LFDT Besu. My name is Matthew Whitehead. I'm a principal engineer at Kaleido working in the UK. And I lead Kaleido's work with Besu, and I also lead the Besu community's enterprise roadmap, which we'll see more about in a second. So those of you who get involved in Besu at a kind of a lower level may see me on Discord, and we may have engaged in conversations and chats and things. You'll see me on Discord quite a lot, answering enterprise specific questions normally, and on the community calls as well. So the aim of this webinar is to give a recap of what's been going on in Besu broadly over the last sort of 12 months. One of the reasons for doing a webinar at this point is there's been quite a lot of work going on in the enterprise space within Besu, and there's been a lot of discussion recently about what we need to do with Besu to make sure it continues to be the best Ethereum client for enterprise, for financial services. And there's a lot of engagement with generally within the open source community and with the other maintainers of Besu, those maintainers who might be more focused on public Ethereum, about how we best make sure that we can continue to iterate on new features that are enterprise focused, possibly at a different cadence to features that Besu needs to progress with in order to maintain parity with the public Ethereum specification and forks. So it felt like a good time to recap a lot of the work that's been going on recently. I'm going to cover a few of the deprecations that Mark talked about. I'm going to cover sort of a release by release basis over the last sort of 7, 8, 9 months, some of the new things that have come in different features. And then I'm going to talk a bit about what we're working on at the moment, which isn't quite ready to go into a release, but is coming very soon. So things you can expect, things you can keep an eye out for in upcoming releases, and things that might give you a reason to just go and look at whether or not those features are likely to be beneficial in your environment. So we're going to have questions towards the end, as Mark said. I'll aim to finish 10, maybe a bit more minutes before the end of the session, so we've got a bit of time for Q&A. But as I say, do come and reach out to me on Discord if there are things that we don't cover today. So just to recap or highlight how the Besu roadmaps are managed. Besu is obviously an open source project. It falls under the Linux Foundation Decentralized Trust. What was some of you may have previously known as the Hyperledger banner. Besu now is under LFDT. And as such, all of the dialogue and discussion about Besu's future is done in the open on both the community calls that are held once a month, but also through the public wiki, which I've taken this screenshot from. Periodically we'll go through our work with other maintainers to update what we have in the wiki roadmap, and that kind of falls into those two camps of public Ethereum oriented features, things like the Pectra fork that has been a lot of work for the clients to get ready for, which I think drops on the 7th of May in about a week's time. And that's driven by the other maintainers and driven primarily by consensus. And then the enterprise roadmap is the part of the roadmap that we at Kaleido lead. And we're very well suited to bring all of our experience running production enterprise financial systems for our customers in order to shape what we think Besu needs to continue to satisfy those use cases, and in order to make Besu easier for those users to deploy and use and run in a secure way. And as with all LFDT projects, all of that is governed and managed by the LFDT program. So everything within Besu, whether it's public Ethereum or enterprise Ethereum, is governed by that overarching LFDT project. So why is LFDT Besu the top choice for financial use cases? Well, it's built with the most secure proof of authority algorithms, QBFT particularly being the one that we recommend, that provides Byzantine fault tolerance, allowing you to distribute and decentralize nodes and have those running among different parties in a secure and reliable way. It has a number of features which are really well suited to enterprises, particularly around access control. So the ability to permission specific nodes to join the network, the ability to permission specific accounts to submit transactions to the network. It's also a very pluggable, we'll talk more about that as we go through the slides. It's a very pluggable Ethereum client. So it's very well suited to enterprise users who might find that it provides 99% of what they need, but where they perhaps need to drop in something custom to their environment, perhaps custom login, perhaps custom authentication or authorization. And being an Apache 2 licensed Ethereum client, it's generally a very enterprise-friendly client. It falls under LFDT, so all of the governance is open and gives enterprise users reassurance that the project is well governed, well managed, and follows due process. Being written in Java with that Apache 2 license, there's a degree more ease with which some enterprises can participate in contributing to Besu compared to the GPL or LGPL Ethereum clients. There's more in the blog article that we've linked to there that goes into more detail around why Hyperledger Besu, now LFDT Besu, is a particularly good choice for financial use cases. So I would recommend going to look for that. The easiest way is probably just to Google that topic there. So let's talk a little bit about some of the things that are going away from Besu before we talk about all the many things that are being added. Obviously, with any software, certain technologies or certain features come into the software and then over time become less relevant or are superseded by better alternatives. And as such, Besu needs to go through the process of removing, tidying up, excluding features that are no longer either relevant to enterprises, relevant to public Ethereum, and which lead to a kind of a bloated, cluttered source code repository, which becomes harder and harder for different users to participate in and contribute to. So I think when we talk about deprecations, I think the important thing is to say that normally, and I think that's the case in all the ones we're talking about here, normally deprecation is a really good sign that better, superior alternatives to those features have been developed, been improved, and become part of Besu before any of these need removing. I'll talk specifically about Tessera and privacy a little more in a moment, and Paladin, which is a project that can be used to replace some of the Tessera privacy features. Just to mention FastSync and proof of work. So FastSync was intended as a way of syncing a node more quickly than full sync, but was sort of a stopgap before a better alternative, which is SnapSync, came along. SnapSync greatly reduces the network load by effectively offloading some of the work of syncing a node and syncing its state tree to the CPU, and only needing to sync over the network a subset of the state and recreating it through recalculating the state tree rather than the way the fast sync works. So fast sync is no longer supported. It's certainly not recommended in enterprise use cases. And so fast sync as a way of syncing new clients with the network, it's much better to use snap sync unless you're trying to build an archive node, in which case full sync still remains as the way to sync an archive node. Proof of work, I'll just mention that as well briefly. Proof of work doesn't have a huge amount of relevance to enterprises. And in the public chain, obviously, since the merge to proof of stake isn't applicable to the public Ethereum chain anymore. So again, it's a technology that was used for a while and has now been superseded by proof of stake. And for enterprises, proof of authority, so IBFT and QBFT, and to some degree, click or click. So let's talk a little more specifically about Tessera. Tessera introduced some really valuable concepts that allowed enterprises to start thinking about how they use EVM chains in a way that still allows them to maintain some control over the privacy of data within their network. And so Tessera had some really valuable concepts like privacy groups, where a subset of the network would see a subset of the transactions, and not everyone would see every transaction's payload and so on. So some really valuable concepts, some really valuable development, but with some downsides that over time have meant that uptake of Tessera has been quite limited, and during the course of that process, alternatives have come to the fore, have been developed and proven out sufficiently that actually we at Kaleido certainly think they present a much better option for adding privacy layers to EVMs, whether they're enterprise EVMs or public EVMs. This talk obviously is not going to go into detail about Paladin, but it's worth just highlighting some of the key features, particularly around the fact that one of the downsides of Tessera is that it's not really possible to implement a private token ecosystem with Tessera because of the inherent inability to expose only a subset of the information to a subset of users. So Paladin introduces a number of different options for privacy frameworks. So that includes the ability to have private tokens that can be based either on zero knowledge technologies or based on notary or issuer concepts, but also to have totally private EVM states between different parties in the network. So you still have the concept of privacy groups as a concept, a subset of parties on the same EVM chain having access to a subset of the information, but with far fewer downsides, and the ability to have a totally private smart contract ecosystem based entirely on any EVM. That could be a Besu EVM or a public Ethereum EVM or a layer 2 or a different layer 1. So I would certainly encourage people who have a particular interest in privacy and EVM and Besu, reaching out to some of these links. We have a couple of webinars that Kaleido has done introducing Paladin and then going into a deeper dive on it. Paladin as a project also falls under the Linux Foundation Decentralized Trust. It's as a lab. So Kaleido's involvement in Paladin is that it's an open source project that we're contributing to, and we're looking to encourage people to look at that as the best way to replace Tessera as a privacy solution for enterprise networks. Okay, some other small deprecations just worth mentioning, things that you may not have seen or missed mentioned in the release change history. So the latest, one of the latest releases to go out, 25.10, finally drops a parameter called host whitelist. It was deprecated quite a long time ago, and Mark has deprecated a very long time ago. But in 25.10 in January this year, finally that's now totally removed. So just keep an eye out for nodes that are running with that, and will now have errors if you try and start them with that enabled. Also, it's worth saying that in 25.4.1, which is the most recent release, the experimental flag for turning on snap sync with BFT, so snap sync with QBFT or IBFT, that was introduced as an experimental parameter while that feature was proven out. And the convention for Besu is that experimental features are prefixed with an X in the CLI arguments, the config arguments. Now, rather than remove the X and change it from an experimental to a non-experimental feature, it's actually removed entirely. So you no longer need to set it. Snap sync with BFT works out of the box. At some point, this will go away. So the deprecation really is to change the default, I think, to true. And then at some point, the experimental flag will just be removed entirely. It won't have the X removed. It will just be removed completely. So snap sync with BFT has now been proven out enough that that's going to go in the near future. Okay, so then let's talk a little bit about some of the new enhancements in recent releases. So I've gone back kind of as far as November last year. I'm just going to go through some of the enhancements since then. Obviously, if you're running a much older version earlier in 2024, there are probably features or things that I won't mention. The Besu changelog and the release list in GitHub gives you a fairly detailed history of the changes between releases. So I've gone back as far as sort of about 6 months ago. So 24.10, one of the features that was delivered to Besu was another feature that's currently experimental, and we'll be looking to, I think, to remove the experimental flag from this feature in the near future. Is a concept called empty block period. So most of you, I expect, will be familiar with the Genesis snippet I've included on this slide, where today you would have a QBFT section with a block period seconds. That might be 1 second, 5 seconds, 10 seconds. So what empty block period seconds does is it allows you to set a different block period if there are no transactions to include in blocks. So you might set a block period of seconds of 5 seconds and an empty block period seconds of 30 seconds or 60 seconds. The way that behaves is that if a new block is due to be produced after 5 seconds and there are no transactions to include in it, then it won't be produced at that time. There'll be a delay, and Besu will wait until the empty block period timer has gone before finally producing an empty block based on the time you configure. So this has a real benefit to delivering something that's, I guess, akin to what things like click offer, where you can have mine on demand. So as a transaction comes in, give it a period of time to add a few more transactions and then mine a block. This is kind of akin to that and allows you to, in periods of inactivity, to produce empty blocks much less frequently. So you're saving space storing the block headers, the empty blocks, and so on. The behavior, if you get halfway through an empty block period, so let's say you get 15 seconds into the timer and nothing's arrived, and then suddenly someone submits a transaction, so it doesn't wait another 15 seconds, it then immediately mines a new block. As soon as you've gone beyond block period seconds and you're within the empty block period seconds timer, if new transactions arrive, there's a short period of time to collect up that one and any others, and then a new block will be produced. So it doesn't mean that the first time you submit a transaction, there's a really high latency on that particular one. So this, I think, is very advantageous for enterprise use cases where you might have activity that fluctuates during the day, and you might have periods of time when there's literally nothing coming into the node. And it should be harmless to set this alongside period seconds. And if you always have transactions, it's just never going to apply. So I'd encourage people to look at this. It's been proven out to some degree now, and I suspect we'll be removing the experimental flag at some point. It's also just worth saying there are also some improvements in 24.10.0 where we improved the behavior when an existing validator that was already voted in as a validator in the chain, but for some reason had to resync from the start of the chain, perhaps a data loss for that particular node. Some improvements in the behavior around that have gone in to ensure that happens much more reliably. A quick mention of 2412. Some of these are features that are just things that I think financial institutions would expect to be there. And so some of the work that we at Kaleido do in contributing to Besu is making sure that those security features and things that production customers just require through their own internal processes or audits or controls, just require their software to have. So some of the things we've been adding are to make sure that all those cases are catered for. So one of the things in 2412 is that we added MTLS support for WebSockets. So now you can have completely client-to-server MTLS security around WebSockets, which is in keeping with what's there for JSON RPC. Then in another feature in 2412 is an interesting feature that allows someone who's making a non-state changing call, so ETH call or ETH estimate gas, they're used to estimate how much gas a transaction is going to use, or to simulate a state change and simulate what the outcome of a transaction call would be. It's a really interesting feature in this space whereby you can issue an ETH estimate gas, and today you can issue it and you can specify the block that it should simulate that transaction on. What you can also do now is you can actually say, I want to simulate this transaction on a specific block, but I also want to apply a custom state change to that state. And that allows me to, ahead of time of knowing a state change is going to happen in the future, let's say I know I've got a second transaction that's going to come along that is going to make the state look like this new state that I've simulated. Then for the first transaction, I could estimate what the cost of that would be. In fact, it's probably the other way around. It's probably we know the first one is going to change some state, but we haven't submitted it yet. And the second one, we can estimate gas based on what we know the state is almost certainly going to be. Then this feature allows the ETH call or the ETH estimate gas call to pass in a diff or a specific piece of state that Besu should use when it's simulating that call. And it allows you to run those against entirely arbitrary state configuration within Besu. Then 25.1.0, first release of this year, MTLS support for JSON RPC. We added some enhancements just to allow the trust store to be in its own file and to allow you to password protect that through a password file. And there were also some improvements to the performance of the ETH get block receipts RPC call. So ETH get block receipts allows you to say, I want all the receipts for a given block. And that itself was added 12 or 15 months ago, I think. And what 25.1.0 introduces is a big performance improvement for that call. So if you're waiting for transactions to be processed in order to determine, to fire events internally within your organization or to determine what you're going to submit next, getting all of the receipts for a given block in one call in a performant way allows you to do that in a much better way. It's also worth saying that 25.3.0, if we move on to that one. So firstly, last year, the idea of transaction parallelization was introduced. There's a really good video by Gary Schultz, one of the lead maintainers on Besu at ETH Denver, where he talks through how parallelization works with transactions. So that was introduced last year as a way of saying, well, if we've got several transactions and we know that they don't touch the same state at all, if they're from different accounts and they're going to different smart contracts, and we know there are no state change overlaps, then we could run those in parallel on the JVM. And we know that it doesn't matter that in the block they're actually ordered. We can execute them in parallel, and we can reduce the processing time for a block. So that improvement was introduced last year, and what we saw in 25.3.0 is more improvements in that space, more cases where it was possible to parallelize transactions safely. So that's currently experimental, using that flag on screen. And again, it can give you for cases where you have transactions that are for different state, for different contracts. It can give you performance improvements in block production. Another feature that we contributed this year relates to users who might still be using non-Besu clients in some of their environments. They might have Quorum, which had some of the early BFT algorithms in. And what we wanted to do was make sure Besu was easy for those users to migrate to. And we looked at the ways that we could do that within Besu, the fact that Besu had in the past some support, some compatibility with Quorum's IBFT protocol. Besu had then created a variant of that called IBFT2, and then QBFT, but Quorum IBFT is something that Besu had in the past and actually dropped because producing new blocks with the old version of IBFT was no longer needed. But what we wanted to do was make sure that actually if users do want to migrate onto Besu and they already have existing state in that format, it was really beneficial if Besu made that really easy for you to do. So what we added in 25.3.0 is what you could consider to be almost like a read-only mode for Quorum IBFT blocks. So Besu will happily read Quorum IBFT blocks in the format that they're encoded. It won't produce new ones, but it will allow you to read in those blocks, and then using a Genesis transition, it will allow you to read up to the block that Quorum chain got up to, and then start producing new blocks in QBFT format from the transition block. So you can go from Quorum IBFT chain to a Besu QBFT chain in one transition. And we tested that in a number of different ways. So exporting data into flat files and then importing it into Besu and starting with the Besu transition to QBFT, or connecting Besu in that if you like, in that IBFT read-only mode. So syncing a new Besu node with an existing Quorum chain, getting to the point where Besu is in sync with the Quorum chain, and then bringing down the Quorum nodes, applying the transition, and starting your new Besu chain with QBFT. So I think this is a good example of where our experience working with financial and enterprise users has allowed us to deliver really valuable features to Besu that just make life easier for those users who want to start migrating to it. Also, we've started seeing, and I think this is going to be a growing trend that the later slides are going to talk about, some improvements to Besu's plugin API. So Besu is very pluggable. It has lots of the key parts of the node that you can drop plugins in. So you can replace JSON RPC calls or add your own JSON RPC calls. You can replace logging. You can replace the authentication and authorization in the stack. You can replace the database that you use to store the data on, and so on. And I think something we're going to see an increasing amount of over the coming 1 to 2 years with Besu is that API is going to grow and become more powerful, more flexible, more complete. And we've already started to see that in the 25.3.0 release. And I'll talk a little more about some of the reasons and the use cases for that later on. We also try to round out the MTLS support statement for Besu by adding that for GraphQL. So all of the interaction points with the node for querying and submitting transactions is all now MTLS secured. Finally, it's worth mentioning a fix for QBFT blog proposal is in there, and I mention that partly because we're always, working with a lot of clients with lots of chains in different states, with different amounts of load through them and different node characteristics of when they start and when they resync and when they add new validators and so on. And so we're continually fixing any issues that edge cases cause in kubeft. And so this is really kind of a reminder for users who are on Besu to keep up to date with what changes are going into the different releases, and to have a really clear approach to how they're going to test and upgrade Besu on a relatively regular cadence to ensure they're getting all of these improvements and fixes. 25.4.0, we added support for changing the mining beneficiary in a kubeft transition. So that's valuable for anyone who's running with a non-free gas chain where the gas price is greater than 0. Allows you just to migrate in different blocks to transition between who the beneficiary is for each mined block. And 25.4.1, one of the things we added as a new experimental flag, and again, this is probably an experimental feature where the flag will go at some point. We won't make it non-experimental. We will just remove the flag when we're happy with it. Is that we did some work to assess whether or not Besu was completely compliant with the kubeft specification, and whether or not there were enhancements we could make to the way that round changes take place, when this is typically encountered when you're perhaps recovering one or more validators, and kubeft goes through this round change process where the time between validators having a turn to propose a block doubles between each turn. And so this flag we've added, and it enables a behavior that is in keeping and compliant with kubeft spec, and allows validators to jump between more than one round at a time in certain situations. And that can really enhance the ability for a chain that has an outage. Let's say 2 out of 4 validators have an outage, and they come back online 3 minutes later. It allows them to start proposing blocks much more quickly than they would do in the previous behavior. So again, the kind of things that people running production systems care about in terms of what's their recovery time to having a working chain again. Okay, so that's kind of covered, I think, a recap of noteworthy features, things to be aware of, things to know have come in recent releases in case you weren't aware of them. I'm going to go on now to talk a bit about things that are in progress. What are we working on right now within the community? What's Kaleido working on for future versions of Besu? So let's just kind of go back to that enterprise roadmap I had on at the beginning of the slide deck, and just look more closely at the enterprise side of it. So the roadmap's broken down into a now, a next, and a later kind of timeline. So there's nothing very granular, nothing particularly committal about exactly what gets delivered and when in this roadmap. But what it does is give you an idea for what do we think the priorities are, how close to completion are some of the things that we're working on, and the roadmap gives you that idea of what's the community kind of driving right now and where does it think it's going. So just to call out some of these, one of the key areas we've been working on has been the ability to use the Bonsai DB storage format, which is now the default for Besu and is going to be what Besu recommends as soon as we have total parity with the Forest DB, is the ability to have archive functionality while still using Bonsai DB. So Bonsai DB, sort of by its very nature, is designed not to store all historic entries in the state tree, which is something that Forest does, and that gives you big benefits, but it also has the downside that it doesn't give you the inherent ability of Forest, which is to go and query state at an arbitrary block in history. So that's something that we certainly feel users, when you swap out a big thing like fundamentally how are we storing all the state and data for a node, and Besu is looking to move to this much improved alternative to Forest called Bonsai. This is where I think we have tried to ensure that that's fine. It's really good. It's really positive. Performance is going to be better and storage is going to be reduced. But it's really important to enterprise users to have feature parity, unless there are really good reasons why you don't need feature parity. So I'll talk a bit more about what Bonsai Archive looks like in a moment. I think, as I said earlier, I think we're going to look at removing the experimental flag from the empty block period option. I think that's coming along. Some of these are kind of small, but they warrant some discussion and some time within the community to decide that's suitable. There's also some work around what does Besu for enterprise look like when public Ethereum starts making changes on a release cadence that Besu doesn't control and Kaleido doesn't control and the LFDT doesn't control. So things like fundamental changes in public Ethereum, like the potential move to Verkle as the way to store the state tree and encode the state tree. That's something that the public Ethereum space is kind of actively working towards. And for enterprise use cases has fundamental implications for particularly for things like the archive work that we're currently working on is very much based on the existing way that state is stored, and so a kind of a near-term thing on the enterprise roadmap is to ensure that that's really good, that Verkle format gives some real benefits to Ethereum, but we do have to ensure we can't just expect people with financial production systems to be able to not have function that they've been reliant on, not be able to do the same things that they've been able to do up until now. And so Verkle as a technology within the public Ethereum space and archive as a thing that we believe is important to enterprise users, that's a thing that needs the community, and Kaleido is going to be leading some of that discussion to understand how do we build that out, and or how do we ensure that as Verkle is being developed, it's developed with all of this in mind. Another item that takes a little small here, called enterprise options for history expiry, is another thing that is being driven partly by the way that public Ethereum is going. And again, the enterprise space can I think benefit from some of those discussions and those decisions, but also has the same problems that public Ethereum is trying to solve. And then finally, we'll talk about some modularity and work that we're doing to ensure Besu still continues to be in the future the best EVM client solution for enterprise, in terms of maybe separating out some of the life cycle from the public roadmap, maybe making it easier to iterate more quickly on enterprise features and so on. So in terms of Bonsai Archive, Forest DB is now deprecated. Bonsai has been the default since about mid last year. And the way that Forest is designed is that you have an entire state tree. So whenever a block changes state, you have all the state tree nodes at that point. And when the next block changes that state, you add some new ones, you change some, but you also keep all the old ones you had. So that means that at any point in time, you can go back and use those nodes in the tree to construct the state, or you just inherently have the state for any block in history. So that's how you today would build an archive node that allows you to say, I want to know the balance of this ERC20 token 4 million blocks ago. Maybe I have an audit requirement, or I need to be able to make queries like that without just taking them from an index, which is a flat database that I have to trust, but having the ability to generate a proof that state was at that point at that block. So Forest inherently gives you that ability, and Bonsai as a database format brings improvements around the ability to look up addresses directly, which is a key requirement of SnapSync, and the ability to, or the inherent design that it doesn't retain all leaves in the nodes, all leaves and all nodes in the state tree, as all blocks kind of continue to iterate and change the state tree. And for public chains, that's perfectly fine. It has a mechanism for going back a few blocks, a few hundred blocks, by effectively keeping enough information to reconstruct it, but fundamentally doesn't keep all the state and can't recreate the state for 4 million blocks ago. That's something we've been actively working on. We've demoed Bonsai Archive. This kind of gives you a quick diff of what you're able to do with the different modes. Fundamentally, you can see Forest on the right gives you historic state for all blocks, recent blocks less than 512 blocks old, and any old blocks, and proofs for those. Bonsai far left can give you all of that, but only for recent blocks. So only going back 512 blocks. What we've been doing is we've been delivering 2 stages. We kind of stage delivery because it's quite there's quite a lot of kind of fundamental design work to do to deliver archive support for Bonsai. We kind of stage delivery of 2 modes of Bonsai. One is that you can get hold of the state, and that's the first drop that's going to come just in experimental format very soon to allow you to start querying state from the tree. But then shortly afterwards, the kind of the finished version or the iterated version, which will actually also allow you to get a proof for that state. So you can say 4 million blocks ago, I want to see the balance of this ERC20, and I want a proof that that was the case. And the like I say, the timeline for this is we've been actively working on it, as with some features in Besu. Sometimes we're gated by public Ethereum features needing to be done by a certain time, like the Pectra fork coming in 7 days' time. The rest of the Ethereum community is not going to wait for Besu to get a few enterprise features in. So we do have that balance to strike with the public Ethereum features. And so some of this work has been done and more or less complete for a while. We have to make sure we work and collaborate with the community well to ensure that we don't disrupt public Ethereum features. And as we see the Pectra fork go live, then we will start to be able to iterate on enterprise features a bit more. And all of this leads on to some of the modularity work in a few slides' time. You might be asking why look, Forest had all of this. Bonsai has some advantages, but Forest had all of this, and we've done a load of work to effectively put that back into Bonsai. This chart shows I think the key reason why it's advantageous, and one of the some of the big key advantages of Bonsai. What you see here, the green line, is over time, over 15,000 blocks of a KeyBFT chain submitting, I think this was 10 transactions a second over 15,000 blocks. And we can see the green line shows Forest DB. So Forest accrues state changes as we submit those transactions, and the storage for Forest goes up and up, and you hit the 240 megabytes mark, I think is where you get to for that node that's synced with the chain. Bonsai DB, without any of our archive features, is the blue line, the bottom one. So Bonsai, to start with, much lower storage, doesn't store all the historic nodes in the tree, and its storage is much lower. Now, what we've done with Bonsai Archive, with proofs, with the ability to go to any point in history and ask for the state and the proof for that state, is the yellow, the orange and the red lines. They've been run with 2 slightly different configuration options for the frequency that certain checkpoints are taken. But the point here is to show that with archive turned on, with state proofs on Bonsai, we're using a very small increment on what Bonsai DB itself uses, and we're using nowhere near the amount of storage space that Forest DB uses. And we're retaining all the performance enhancements that Bonsai gives in terms of looking up an individual address to do a snap sync for a new node joining the network much faster. So this hopefully explains why what we're looking to do is give really the best of both worlds. We're giving all the capabilities of Forest DB with all the performance and storage improvements that Bonsai gives you. History expiry. We've got about, I'm going to try and go for about 5 more minutes, and then we'll maybe pause for questions. So history expiry is a really interesting topic for the future of enterprise Besu. And it's something that the public Ethereum chains have been wrangling with, purely down to the fundamental design of a blockchain, that it just grows forever. You add new blocks, you change state, and things grow forever. Now, in terms of state, we talked about bonsai and how it doesn't keep all the state because it doesn't really need it. And public Ethereum is pretty much encouraging doing that. But what about blocks? What about block 2 and block 3 and block 4 on public Ethereum? And for your enterprise chain, what about blocks 2 and block 3 and block 4? And all the millions of blocks that you're going to produce and continue producing while you're running this chain for indefinitely. So this term is history expiry, is used to kind of describe an approach to deciding, in certain cases, to remove old blocks and old receipts. Now, I should say kind of upfront, obviously, this doesn't assume you're never going to need them. What it says is you really don't need them for most of the nodes in public Ethereum. Most people aren't going to ask for block 2. So you need mechanisms to go and get it if you need it. But what you don't need is, by default, every node has it. And that's really what history expiry is trying to address. And for public Ethereum, different approaches are being used to give fallback options to go and get blocks. But enterprise chains are going to have exactly this issue, and they're not necessarily going to want to do exactly what the public Ethereum network does, and they might not be able to. The public Ethereum network is partly going to be using technologies that are run by large numbers of decentralized operators, and financial institutions, even if they're running across multiple parties, aren't necessarily going to be able to use those same approaches. So an option that we're exploring, there has been an option to do some of this, and we've been proving it out more. It's not been documented. We've been running tests, and we've been looking at how effective it is and what options it gives you, is to say that perhaps if we might look at Besu having an option where for some nodes you can say, I am going to drop old blocks. I'm going to keep the last 10,000, for example. And different topologies of nodes might require you to have some that still have everything. But for other nodes, in order to produce and validate new blocks as a validator, not all validators need all old blocks. So an example of how this might look in the future might be that we've got 4 validators here. Might be that 2 of those, because we don't need to replicate all of our old blocks everywhere, 2 of those might have history expiry turned on, and they can continue to produce new blocks, to validate proposed blocks, and the chain can continue running. And all they're going to keep is a small recent history of, near the head of the chain. And then we have some nodes in the network that are going to keep everything. So some of the validators might need to keep everything so that you ensure you have got each block at least in one place. Your JSON RPC nodes might keep everything. You might have an archive separately which keeps everything. But this is just starting to paint the picture of, well, does every component in the chain have to keep everything? And this is something that Kaleido has actively kind of worked on to prove out what's possible. And I think you'll start to see more discussion around what the safe topologies are that utilize this within enterprises. Let's get through there. 2 more, and then I think I'm going to try and cover these in 2 minutes. So last couple of things. One thing that we wanted to do based on our experience of setting up networks across multiple parties is that today, if you want to run validators, let's say between 2 organizations, and you've got the 4 validators here, QBFT traffic is only gossiped between validators on the network. So if you set this picture up today, you don't have a chain that's producing blocks. What you have is 4 validators all trying to propose blocks, but 2 of them never hear about the proposals from the other 2, and vice versa. So this picture here is not, you can't build today. You can't run your validators behind another validator that's maybe more at the edge of the network and have that connected to a non-validator on the edge of someone else's network. And so you're limited to how you can deploy your validators and what topologies are available to you. What we've been doing is enhancing Besu with a feature that allows you to choose that your non-validators, and it could just be some of them, gossip all the QBFT traffic between the nodes that they're connected to. So in this case, validators on the left-hand side can talk to their non-validator, and that one's configured to gossip all of that traffic to its peers, which means that on all two, they receive the block proposals and vice versa. And so the chain can continue mining. So this is something that we'll see as a feature to enable very soon. And I think the final topic for me is really this one, just about modularity. So Besu currently looks a bit like this on the left, where you have the core source code for the EVM and the transaction pool. You have a really powerful plugin interface, and some of the components like the database, the RocksDB, use that plugin framework. And then you have all the governance around producing releases. You have the testing, LFDT governance, release lifecycle. So this is kind of how Besu is built today. We talked about the fact that we've had to hold out on some enterprise features while public Ethereum is getting to a fork and can kind of open for business again. What I think we're going to start moving towards is maybe a model where Besu Core has all the public Ethereum features, and we move enterprise functionality into a different environment as plugins. And what we end up having is the ability to iterate on enterprise features in their own repository, out of step with the core release lifecycle, and then to drop those into the core release and produce enterprise releases that comprise both the core and these enterprise features. And this whole area of modularity, where is the code hosted, how many enhancements are needed to the plugin interfaces to make this possible, we're heavily involved with right now. But this is really the direction that I think we're going to ensure Besu is a really healthy, vibrant community where people have kind of low friction to get involved, and Besu can keep up pace with enterprise requirements and public requirements at the same time. Okay, key takeaways. I'll just leave this on screen. I think I wanted to highlight the new Besu Certified Professional exam. I've just mentioned it down there. I'm not going to read through these now because I think we've got about 6 minutes for some questions. So I'm going to open the floor to Mark. Are there any questions, Mark, on chat?
Yeah, there are. And thank you, Matthew. We've got a few. And just for the listeners, if we don't get to them all, we'll try to follow up either via email or on the Discord. But one, because it's connected to your last webinar, Matthew, Andre asked, can you give us some insight into the latest performance tests? And are there any tuned for Besu caliper configurations?
Yeah, so obviously you saw on the performance webinar we did a while back that we've kind of proven out some pretty high performance in Besu. So I think the takeaway at the moment is that the main work around Bonsai is going to bring some of the performance improvements, and the work on parallelization is going to bring some performance improvements. Caliper is a tool we use and is fairly easy using just configuration files to run against Besu nodes, and it's something that we used to produce some of the metrics for that previous webinar. We've not. You probably saw it. You know, I covered quite a lot of content. I didn't talk a huge amount about performance in this slide deck. It's probably something we're going to come back around to as we kind of see a whole load of enhancements come in, and we'll probably get to the point where we want to do a proper reassessment of Besu's performance. But I should say that I think the main thing I should say is what we do is make sure that we performance test Besu before, for example, Kaleido releases a version of Besu for its users. So performance is still very high. What we haven't done is recently run dedicated performance tests just to show a new set of numbers, but that's perhaps something we could do in another webinar at some point.
And then Matthew, Jim Mason asked, are there updated training tutorials on Besu for 25.3? And do they also use Firefly?
Updated training tutorials. So obviously all the documentation is updated with each release. So everything would be covered in there. I think the Certified Professional exam points at some material. I don't think it points at anything Firefly specific. I'm not sure when you talk about are they linked to Firefly, maybe that some of the Firefly material links perhaps to Besu. I'm not sure if Besu tutorials work the other way around. So no hard links that I can drop in here right at the moment, but all the documentation does get updated with each release. And I think there are probably documents in the open source wiki which talk about some of the features in more detail. But yeah, maybe feel free to reach out to me on Discord, Jim, or an email, and we could maybe follow up a bit more.
Perfect. And then Matthew, if you want to share that last slide, just pointing out to everybody that the best way to get a hold of Matthew is through the LF Decentralized Trust Discord. So we'll share out all these materials after the fact. So you have easy links. LF Decentralized Trust obviously has a lot of great blogs, webinars on Besu. And then if you want to speak specifically about a use case and how Besu might help, the team at Kaleido is always available and would love to sit down and talk to you about that. So with that, I think we're coming to the coming to the end here, Matthew. Do you have any kind of parting words?
No, I think that recaps really nicely, Mark. I'd certainly encourage people to look at the certification that was released maybe a month or so ago. Sometimes just going through a certification and the work to get up to speed ready for an exam can teach you a lot of useful things about software that you didn't know in the first place. So I'd encourage people to look out for that. And also just keep an eye out for releases over this year because there's a lot of new function coming.
Awesome. Well, thank you so much, Matthew, and thanks everyone for attending. Happy Wednesday.
Thanks, Mark.